so let people join. We will be starting in 2 minutes. Okay, so let's start. My name is Mayank Tayal. Today I will be taking the contest discussion on Codeforces contest 859 day 4. So let's start with question A. So plus and minus. You are given three integers a, b, and c, such that exactly one of these equations is true: a plus b equal to c, and or a minus b equal to c. So output plus if the first equation is true, otherwise minus. So we just need to output plus when a plus b is equal to c. So this is the brute force. We are given three integers. We just need to check is a plus b equal to c. Then we will output plus, otherwise minus. Uh, this is the code that I submitted. Uh, Here is the code. We are running over. We have case. We have this number of cases. We are including the number of these cases, and now for each case we are taking a, b, c as input. Now if a plus b is equal to c, then we will be print plus. Otherwise, we'll print minus. So this is the whole code for this. This is the code for this problem. Moving to problem B. So me and Bianca are playing with bags of candies. They have a row A of and bag of candies. The ith bag of has AI candies. The bags are given to the players in order from the first bag to the nth bag. If bag has an even number of candies, he grabs the bag. Otherwise, Bianca grabs the bag. Once a bag is grabbed, the number of candies in it gets added to the total number of candies to the players that took it. Mia wants to show, so he wants to reorder the array so that at any moment Mia will get strictly more candies than Vinika. Help Mia find out such a ordering. So we need to order the bag such that Mihita has higher number of candies at any moment. So we can just do is this then array. So for every element we have a choice that uh, this is taken by Mihika or this is taken by Binyal. So we can just reorder this that we will arrange all the stacks that has even number of candies in the front. So when we reach at this point, Mika will have maximum number of candies, and after that, uh, the candies, all the odd number of candies we will place. So if Mika when can win, then this is the case. Otherwise, she will not be able to win. So we have an array. We will just put all the even number of candies in the front, and we will check that by doing that if Mika can win or not. If she can win, we will share output yes. This is my code for the problem. So we will take we will input the array and we will take two integers, sum1 and sum2. So if the number of candies in the stack is even, then we will add that to sum1. Otherwise, we will add that to sum2. Now, if sum1 is greater than sum2, then Mia will win. We have a case when we have a win, so we'll output yes. So we will check for this input. So we got output says yes, no, and no, which is the expected output. Moving to the next problem, problem C. Now find its place. You are given a string S consisting of lowercase Latin characters. In an operation, you can take a character and replace all occurrences of this character with 0 and replace all occurrences of this character with 1. Is it possible to perform some number of moves so that the resulting string is an alternate binary string? For example, consider this is the test case. An alternating binary string is a string of zeros and ones such that no two adjacent bits are equal. So we'll take a test case to see the logic. ABA CABA. So what we'll do is we'll take one. Now we will replace all ones with uh, simply we can do is we'll replace all the characters at even numbers by 0, all the characters at even number by 0, and all the characters at odd numbers or odd places by 1. If we can do this, then uh, this is the answer. Otherwise, we will not be able to do this. So for this, if we replace uh, even number the characters at even numbers by 1, so B and C will get the value 1. So sorry, B and C will get the value 0, and A will get the value 1. So there is no interaction between this, so we can do this. So for this, uh, this is my code for this. So what I'm doing is I'm inputting a string, and now I'm maintaining an array for each characters from A to Z. Now, firstly, I'm taking the value for them is -1. So whenever so now we will iterate over the string. So we'll check if the character is new. We have not seen that character before, so we will just place it. We'll take it equal to index divisible index divided by 2. So whenever we have an even index, we'll place it to 0, otherwise 1. So now we will check if we have seen this index before also. So we have to see that if there is if that was the case that if it was the case that previously it occurred at even position and it now it is occurring at odd position, so that case is not possible. So in that case we will return false. We'll take we are maintaining an variable answer, so we'll in this case we'll output will change the value it as false. So if the answer is if the answer is true, then we'll output yes, otherwise no. This is the test case for the problem. So we are getting the exact output as the sample output. Yes, no, yes, yes, no, no, yes, no, yes. Moving to the fourth problem, or queries. You have an array you have an array. Ask you queries of the form: if we change all elements in the range AL to AR of the array to K, will the sum of the entire array be odd? Note that queries are independent and do not affect future queries. So we have an array, and we are given for a query we are given this subset, and we have to change all the elements into this to K and check if after doing this the resulting array has some or sum as odd. So we will what we will do is we will maintain a sum array. So for this query we will found the sum of the new array. So the sum of the new array will be the total sum of the array minus sum of the previous array, sum of this previous subarray, sum of this previous subarray plus number of elements in this subarray times k. So we just need to check if this value is odd, then we will output yes, otherwise no. For calculating the sum of this subarray, we are using the sum array. So for this sum array, at position I, we'll be storing the sum of uh, will storing the sum of all the uh, if this L we have an subarray from L to R. So we have a prefix array that stores sums to R. So the sum of this subarray will be prefix array of R minus prefix array of L minus 1. So this will be our logic for this problem. We'll be implementing this. This is my code, and this is the subtest. So what I'm doing is I'm first taking an input, and after that I am maintaining up some prefix array of size n plus 1. So at place 0 it stores 0, and for the next time terms it stores the sum of the prefix array. So now for each query ABC, I will checking if the some of the new sub if the some of the array that some of the newly formed array is odd or even. If it is odd, then I will output yes, otherwise no. So for finding the sum, what is it doing is uh, someone stores the total sum of the array. So now, and this value sees the new sees actually k we are for this array from A to B, we are marking all elements as C. So this will be our sum of the new subarray. Now we need to subtract the sum of the previous subarray. So sum of the previous subarray will be sum of B minus sum of A minus 1. So we will sum this all and check if this sum is odd, then we'll output yes. So this is the output. This is the output. This is exactly what we got. Moving to the fifth problem, this is an interactive problem. So before the last stage of the exam, the writer conducted an interview. He gave Gone and piles of stones. That pile contains 8 stones. Each stone is identical and weighs 1 gram, except for one special stone that is a part of unknown pile and weighs 2 grams. Gone Gon can ask the director questions of one kind. He can choose K piles, and the director will tell him the total weight of the files chosen. More formally, Gon can choose an integer K and K unit piles, P1 to Pk, and the director will return the total weight of these piles. Gon is tasked with finding the pile that contains the special stone. However, the director is busy. Help Gon find the pile in at most 30 moves. So what we are given is we are given an array of size n, telling us the number of stone the pile contains, and from that we need to find the pile that contains the uh, stone with weight 2. So for this we are given this array. So for every pile for ith pile its weight will be ai. For ith pile it contains ai stones, and if it doesn't contain the stone with weight 2, then the sum will be ai only. But if it contains the stone with weight 2, then its sum will be ai plus 1, and there will be only one occurrence of this type in the array. So what you can do is it's pretty observant from the constraints that we need to apply binary search. So how we apply we'll be applying binary search. So what we'll be doing is we'll taking this array of n size and we'll be partitioning in two parts, n by 2 and n by 2, and we'll be checking if the sum of weights of this subarray, if the sum of these weights of this part exceeds the number of stones in that, then that the that stone with weight 2 is contained in this subarray. So then we will take this part and proceed further. And if it is equal, if the number of stone, if the weight of the stones is equal to the number of stones, then it doesn't contain the stone with weight 2. So we will be searching in the right part. So this is the logic you need to apply. Sorry, I think Codeforces has crashed. Oh yes, so we were at the fifth question, interview. We saw the logic for this question. Now we'll be seeing the code. So this is the code for this. So we first need to input the size of the array and the number of all the elements of this array. So now we'll be applying binary search. So low bound will be 1 and upper bound will be n. So we will be applying while loop till l is less than equal to r. We'll take the middle element of this, and the total number of elements in the subarray will be made minus l plus 1. We'll be outputting. So we are taking the first subarray to be l to mid. Left subarray to be l to mid, and the right subarray will be l plus 1 to r. So we are outputting all the elements of from L to mid, all the numbers from L to mid, and taking the sum of the number of stones in them. So for, as it is an interactive query, after outputting each line, we need to output flush. So after that, we'll get an input from the uh, compiler that will be the total weights of this of the piles we have output. So if this weight is greater than the number of stones in the piles, then we'll be searching in the left subarray from L, in the L to mid. We'll searching it, and if it is equal to if the weight is equal to number of stones, then we'll be searching in the right subarray. So uh, after that uh, from the will will repeat it till l is less than equal to r, and after that answer will store the our answer will be the number of the pile that contains the pile with stone 2, stone with weight 2. And after that, it is the again, as it is an interactive problem, after outputting the answer we need to output cout.flush. So I did submit this problem. I did submit the code in the contest. So I will not be submitted it again. And again, the reason is the code force is not working today fine, so it may crash while I submit. Moving to the sixth problem, bounce ball. You are given a room that can be represented by a n cross m grid. There is a ball at position I1, J1, the interaction of the row I1 and column J1, and it starts going diagonally in one of the four directions. The ball is going down and right, denoted by down right. It means from ij to I plus 1, j plus 1. If going down left, so I comma j to I plus 1, j minus 1. Upright, I minus 1, j plus 1, and up left, I comma j to I minus 1, j minus 1. So I have this there. So we have this here. After each step, the ball maintains direction unless it hits the ball. In this case, the ball's direction gets flipped along the axis of the ball. If the ball hits a corner, both directions get flipped, and any instance of this ball is called bounce. the bounce number stops. In the above example, the ball starts at 1,7 and goes DL until it reaches the bottom ball. Then it bounces and continues in the direction UL. After reaching the left ball, the ball bounces and continues to go in the direction UR. When the ball reaches the upper wall, it bounces and continues in the direction DR. After reaching the bottom right corner, it bounces again once and continues in direction UL and so on. So we are firstly starting with 1,7. So and moving down left. After that we reach the bottom wall. It will bounce and move upper left. Then it will reach this cell, and after that it will bounce and reach 1,3. After that, it will go down and right and will reach 5,7. Now this is the corner, so it will bounce back. So now we have to we are given another coordinate I2, J2. Now we have to find if we can reach the coordinate I2, J2. If we can, we have to find the number of bounces it takes to reach there. Otherwise, we need to output -1. So the logic behind this problem is this is the grid. So if we start from this place, it will go like this. Uh, line equal to y, line like y equal to x, and then it will be move move in a line perpendicular to this, and then again perpendicular to this. So these two lines will be parallel, and it will again form like a structure like this. So doing this, it will be repeating this. So after doing that, there will be a stage when firstly we define a state. We define a state. So a state we can define as I comma j, the point where it starts, and the direction in which it goes. So we are defining it as a state. So we can. So the logic behind this problem is, as it is moving like this, it after some time it will repeat this state. Uh, that we can see this. That we can see like it is moving only in lines parallel to y equal to x plus c and y plus x equal to c. So when we has it, so see, think of the word case. When it has iterated of all these lines, then there is no line to there is no direction for it to go, but the ball is not stopping, so it has to repeat. This is the worst case. And also, for calculating the worst case number of steps, it will be the number of lines it can move. So the number of lines equal the number of flags parallel to y equal to x will be of the order of m plus n, and same for y plus x. So it it is in the given constraints. So 25,000 is the given constraint. So 2 times is that, it's the order of 10 per 5, taking number of 10 per 5 lines max at max. So what we have to do is we will be marking I comma j comma direction as a state, and after that, like starting from this point, we'll marking it as a state. So this point comma direction, and if after some times it reaches this state again, then we'll be big. And if that point is not reached yet, then we'll output -1, because it will not be able to reach it at any cost, because if the state if it has repeated that state, then it will continue to repeat all the states in the order. And uh, for the second step, we have to check if it will be passing through this state or not. So for that, think of this line. Like we are moving from 7,1, sorry, 1,7 to 5,3. So what we are doing is, uh, for the first coordinate, we are doing minus every time, and for the second coordinate, we are doing plus every time. So we have to this is a sequence in which the line is moving. So we can check if the x coordinates plus y coordinate of the state is equal to 8. Then this line will pass through that state, and we will output uh, this line will output from that state, and we can just output the number of bounces it take to reach to that state. In this state it started from 1,7, so the number of bounces will be 0. So now for a state we have 4 directions to go. So this up left, up right, down left, or down right. So we have four cases, and for each case, like our direction, in this case our line is moving from down left. So after that there are 3 cases, like if it reaches the bottom wall, and then after striking it, it moves to up left. This is one case. And for each case we have 3 cases. And the left wall arrived earlier. So after left wall arrived, and in the third case, so for and for each case we have 3 cases. This was the logic. Now we will seeing the code for this problem. So the code for this is lengthy, but it's basically it's easy. We just need to make the cases. So firstly, I'm inputting the variables, and after that, I'm storing a state iterator, it. In it, if for each direction I'm storing a state, like for upper left, I'm marking iterator as it as 1. For upper right, I'm marking it as 2. For down left 3, down right 4. So now answer is a variable that is counting the number of bounces it had taken, and in the map I'm storing the all these visited states. So we will looping till we do not find a state that is repeated. So firstly we are checking, and after that we'll just output the number of bounces. So for each iteration of the loop, what we're doing is we'll firstly check if this state has been visited before or not. If it has visited, and if the state is visited and we have not found the point x2, if we have not found the point yet, cell yet, then we'll output -1, and we'll break off the loop. Otherwise we'll mark the state as visited. Now after that we have 4 cases to see. we'll see uh, we'll see which state is. We have 4 cases. It can be upper left. It can be 1, 2, 3, 4. According to that, it can be upper left, upper right, down right. So for each case, like upper left, we have to see. We'll just making the states. If like for the first case, we first have to see if the x2 comma y2 state can be reachable from here or not. So for that, like we are moving for upper left. So in the upper left case, what is happening is it's moving from I comma j to I minus 1 comma j minus 1. So for each, so what is doing is it is maintaining this line is y equal to x. So it is maintaining its difference. So we just need to check if x1 minus x2 is equal to y minus y2. Then we pass over this state. And second is when it starts from in the first case, in the first step, when it starts from a certain cell, then it may be that that state lies in this line, but in the backward, so it will not reach the states. So we need to check this also. So we'll have to see that the constraints, like the point line in the direction and in the front direction of the point. So we'll see, and if we can if the point lies in the line, then we'll break. Otherwise, we need to update the state. So for updating the state, we have three cases like we discussed before. We'll make three cases, like if x equal to x1, x1 equal to y1, then it will reach the corner and will bounce back. Otherwise, it will reach the upper wall of the left wall. So for each state, we'll update the states accordingly. And these are 12 states that we need to update, and that's all. We don't need to anything. We'll run this. So 3 minus 1, 1 minus 1, 4 0. So this is the output required. So this is an easy problem. The only thing is we need to figure out that it will maintain the state, and after some time the states will start repeating. Plus, quite the code for this problem is somewhat hard to write, and we need to think carefully after writing each step of the code, because it has many cases, like 12 cases for this problem, and you can be wrong at any step, and if you're wrong, then it will give wrong answer. Now coming to the seventh problem. So the only difference in the two versions of the problem is that constraints are lower. Initially, array A contains just number 1. You can perform several operations in order to change the array. In one operations, you can select some sequence of A and add into A an element equal to the sum of the elements of the subsequence. You are given a final array C. Check if C can be obtained from the initial array A by performing some number of operations on the initial array. A sequence B is a subsequence of sequence A if B can be obtained from A by the deletion of several elements. In other words, select k distinct elements and insert anywhere in the array new element with the value equal to some of the elements of the subarray. So firstly, we are given this array. So the better thinking is for the first step, we can think is as we will sort this array and we will generating all the numbers in that order only. Because if we are generating a larger element, we will be we go for from a larger element, we cannot generate a smaller element. So that smaller element will be generated earlier only. So firstly, we have element 1, and from that we have to generate all the elements. So for that, we can see that for the constraints, like seeing for this constraint n equal to 5000 and ci equal to 5000. For this, we can see this as an abstract problem. So firstly, we have element 1. So from 1, we can make 1. So, 1 1 1. After that, from 1 we can check some number of ones and we can make another element. So taken for this case 5 1 3 2 1. 5 1 3 2 1. So firstly we have 1. From that 1 we can make another one. So and the sum of these two we can take the sum and it will be 2. So now taking the subsequence, we can make 3 and 3 and 2. From this we can make 5. So what we are doing is we can think it of as a knapsack problem for these constraints. Like we'll be maintaining a knapsack, and for each we will be seeing what are the elements that we can make. What are the sums that we can make, and what are the sums of the elements that we can make, and cause every element can be of maximum 5000, and we have 5000, n is equal to 5000. So the time complexity will be 5. The time complexity of this will be n into maximum size of knapsack. So it will be n into 5000. So this will be equal to 2.5 into 10 power 7, which lies under the constraint. this side will pass. So what we need to do is we're making a knapsack and see from these elements what are the sums that we can make. So like from one, so like from firstly we have element firstly we have this element one. From one we can only make one. So when we have make, now we have two ones in the array. Now from this we can make one and two. So we want to make two, so we'll be selecting it, and now our new subarray will be 112. From this we can make 1 2 3 4. Now we have three in this array, so we will be taking three. So from one, now we have 1 1 2 3. From this we will be making five. So at every step we'll be making we'll be seeing what are the values, what are the sums that we can make from this, and we will choose according to this. We'll be choosing the next element of this array, and if the next element of the array doesn't lie in our knapsack, then we cannot make that array. We cannot make that element. So this will be our approach. The code for this will be simply knapsack. Now we'll be seeing this. Now we'll be seeing this problem for harder constraints. So for harder constraints, we have n equal to 2 into 10 power 5 and ci equal to 2 into 10 power 5. So the time complexity for the previous algorithm will be n into c max. C max is 2 into 10 power 5, and n is also 2 into 10 power 5. So the time complexity, the number of steps goes up to around 4 into 10 power 4 into 10 power 10, and the maximum number of steps that can the number of maximum number of steps that the code can pass is around 10 per 8. So this is way higher than that. So the knapsack approach will not work. We need to think of something else. So now think of this: one 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 two three five. So when we have one, from one we can make one. Now we have from one we can make one and two. From 1 1 2 we can make 1 2 3 4. Now from 1 1 2 3 we can make 1 2 3 4 5 6 7. So you can notice one thing there is that uh, for at any step when we have this array, we can make all the elements from one to the some of the elements of this array, some of these elements of the array that we have. So at this we have sum as one, so we can make from one to one. We have this sum one, sum of this is two, so we can make one and two. The sum of this is four, so we are able to make all the elements from one to four. Now for this the sum is seven, so we are able to make all the elements from one to seven. Now seeing for this again for this array, the total sum of this array is 12, so we'll be able to make all the elements from 1 to 12. So what we just need to see for this array, for this problem we just need to see this. We'll just firstly sort the array, and we'll see that we can make a new we can make a new element from there, from that, and the sum of the new element we want to make should be less than equal to the sum of all the elements that we make. So now taking this test case 7 1 5 2 1. So first we're making two. First we have one. So from one we can make one, and now we can also make two because 1 plus 1 is 2. Now we have elements 5 and 7. So but the total sum of this is 4. So we cannot make 5. So the answer for this will be no. We will not be able to make it. Seeing the code for this. So we just need to input the array, and we will just we'll sort it, and we have to check. the first element should always be 1. The smallest element should always be 1, because we are given that the array initially contains the number 1. So the first number should always be 1, and after that we will maintaining a variable sum, and we'll be checking if the ith element is greater than, or if the ith element is greater than the sum of all the elements from 1 to I-1, then we will not be able to form this element, and the answer will be no. Otherwise, and otherwise we will just adding this element to the sum, and we'll be proceeding. We will proceed further. Um, Checking for the subtest. So this is the answer: yes, no, yes, no, yes, yes. So this is what we are getting. Uh, it's a simple brute force problem. The only thing we need to notice is that for the array, we can make all the elements from 1 to the sum of the elements. We have discussed all the now we have discussed all the problems. We will just ending the meet now. Okay, thank you. This was the contest discussion for contest 859 day 4. Thank you. Bye.